Well, I appreciate you for joining the podcast. For folks that don't obviously know you, can you introduce yourself? Let everyone know what you do, where you work, and all that good stuff.
Yeah. So, thanks for having me. My name's Nick Castillo, and right now I'm a PhD candidate at Florida International University, and I'm supported by Crest Cache. So, it's a Center for Aquatic Chemistry and Environment. So, they support me in the research, but PhD candidate, and I study fish ecology and ecotoxicology. So that's my academic life, but I'm also a backcountry, so inshore fishing guide. So I do
Awesome.
fishing trips out of the Keys, Biscayne Bay. And I kind of found the perfect little like professional career, as far as being a coastal researcher with my passion, you know what I mean? Like fishing.
Yeah. So, do you do
Um,
any like charters or anything? Like, do you charter fishing, all that good stuff in Florida?
Yeah, so I run charters in the Keys for serious anglers. I do family trips in a bigger boat, but I have a small technical polling skiff, so it's a Maverick, and I run trips looking for bonefish, the fish that I study, and all the other ones that we like to catch.
Dude, you landed the jackpot dream job, man.
I know, right? Both jobs have me on the water.
How long you been doing the charters?
So right after I graduated undergrad, I did my undergrad in North Carolina at Duke University. And once I graduated, so I'm from Florida.
Okay.
And once I graduated from there, I'm like, this is too cold, right? And so I loved it, but I'm like, it's too cold. So I went straight down to the Keys and I taught marine science. And then in 2015, 2016, that's when I started guiding full time. Did that through 2018 when I started my PhD.
So, unrelated topic to the discussion we're going to get into, but why are the beaches in Florida so much prettier than the ones in Texas? Have you been to any beaches in Texas?
I haven't. What are your beaches like there?
Oh gosh, dude! Well, first off, the water's not clear. So I took my family to Florida, about a month ago, and it was my first time to Destin. We visited Destin Beach, and that
Yeah.
the sand is like white and clean and pretty, and you don't feel filthy when you leave the
Yeah.
healthy. Like here in Texas, Surfside Beach is the nearest one we have. It's like 18 minutes for where I live, and it's just not. I'm not talking about like the way the city maintains it, because the city maintains it pretty well, but the grit and the feeling that you have in the water, and when you leave you feel dirty.
Yeah.
What's the difference? Like, why is it so nasty here in Texas?
There could be a couple things. I mean, it sounds like where you're at, you're potentially near some like estuaries, some river input. So maybe that brings in a little bit like dirtier water. You're mentioning a little dirtier. Here in Florida, a lot of our like rock bed is limestone, and that has to do with like some calcium carbonate. So we have a lot of the material that actually makes the sand around here and in the water. And we also are a little bit tricky in that we bring in a lot of sand that's not natural and
Oh,
supplement our beaches.
you sons
Yeah,
of bitches! That's the
I
that's
know,
the
right?
trick.
We're faking it. Who knows where that sand comes from? But
Yeah.
yeah, we're supplementing a little bit.
Man, so when I was in Florida, I like to read the local news and places I go to. And one of the articles that popped out was how pharmaceutical drugs are in these fishes. And you said you study bonefish,
Yeah,
which is a crazy, because that's something that I've never thought about. We always hear about plastic in the ocean, chemical spills in the ocean, stuff like that, but we never real, or at least the news that I look into or social media that I follow, I've never seen anything talked about on the pharmaceutical side of those drugs entering the waters and now it being part of the ecosystem and the fish. So your
yeah.
study, that's one that you led. So is this something that you and your team kind of developed, and you knew this was occurring, or did you stumble across this?
Yeah, so I mean, to touch on what you said first there, it's like when we think of water quality, like you said, plastics, we can see that. We can see an algae bloom. We can see all these other things that are really visible, and we go, okay, that's a threat, that's an issue. But these small contaminants, pharmaceuticals, you look out in pristine water, it looks pristine, but those drugs, they're there. So that that's one thing, is to potentially why it kind of just goes the wayside, and it's just a new field in general too. But I work with Dr. Jennifer Rehage. So she's the head of our lab here at FIU. And we also collaborate with the Bonefish and Tarpon Trust. So they're a non-for-profit, and they study bonefish, tarpon, permit, and the habitats that support them. So they funded this project, but as science kind of goes, some of the real science at a conference doesn't happen during the presentations. It's at the bar afterwards when you actually start talking with all the scientists. So back in 2016, Jen, my advisor, was talking with our collaborators in Sweden. So we work with these Swedish collaborators, top of the field in ecotoxicology. So that's contaminants in the environment and studying how those affect fish behavior. And they were discussing like, okay, we have all these bonefish in a tank. Some are from Florida, some are from the Caribbean. And those Florida fish are like wigged out. They will freak out. They'll swim all over the place, bash themselves into the side of the tank to the point they might kill themselves. And they're like, what's going on? And, the Swedes are like, well, drugs, maybe. So we took a couple samples, send them out. And lo and behold, every sample had a number of drugs. And what was alarming too, in those original samples, it had an opiate, tramadol, which is like a really powerful opiate. So they're like, whoa, okay, there's something here. And that just kind of spurred the whole study, which started in 2018.
So that was just a plain discussion. Like it was just like a hypothesis, I guess, of there was no, like, it was just a guess basically.
Yeah, it's like a guess. We were fish ecologists. We were talking with people that look at the same thing from a completely different perspective because like their expertise is different. And that's where the magic happens. When you get people that are experts in different things, they look at the same problem and go, oh, it could be that based on what I know. And so that's kind of how it happened. We're like, okay, this could be the issue. And it was a big thing because bonefish are really important recreationally. We love to fish for them. They're found in South Florida, but the population in South Florida declined dramatically compared to the Caribbean. And so one of the things we're looking into is like, why? And then at that moment, it was probably when we realized, okay, drugs in the water might be one of the whys. So let's look into this.
So if it's safe to assume that these pharmaceuticals that are in bonefish, they're probably in other fishes too, because the predator fish will eat those bonefish and then those chemicals get passed down from fish to fish, right? Is that safe to assume or not?
Yeah, definitely. So we tested the bonefish and we also tested prey items. So small crabs, shrimp, and so forth, to look at like what would a potential route be of exposure to these fish? Is it from what they're eating? Is it from the water? And the prey items had almost twice the amount of drugs that the bonefish had. And bonefish, they live in coastal ecosystems close to people. And those prey items they're feeding on, everything else there feeds on them. So if it's in the prey items, the small little things in the food web, it's in all the other fish that feed on them. And it's also in the water. So anything that's there that's breathing it in. So it's definitely safe to say that it's there. But, our study is fairly new as far as looking into the marine environment. I mean, just this field in general is really new.
Yeah,
but
no, that's scary, dude. So what's the most potent drug that you picked up during the study? What's number one that you saw across all the bonefish?
So most potent drug. One of the drugs, like let's say a drug type that we find a lot of are anti-anxiety medications. So drugs for depression, for OCD, some stuff even as intense as like for schizophrenia. And we found a lot of those drugs. So one fish in particular that was really contaminated had 17 different drugs in its system, 8 of which were anti-anxiety drugs of a different sort. And some of those were above a level that could cause an effect. So like when a doctor would prescribe you medication, they're looking at, the recommended dosage so that it reaches a certain concentration in your bloodstream. So then the drug actually does something. So some of those drugs that we found in that fish were over 300 times what you would look to have in your own blood. And it's crazy. And then we actually do know a lot about what these anti-anxiety drugs do when fish are exposed, because they actually change behaviors. And that's one of the interesting things about pharmaceuticals. You're not killing a fish that's exposed. It's not like some other sort of contaminant, but it has these smaller, more subtle changes like in behavior that can really affect the whole population.
So what are some of these behaviors that you're seeing? And I know you talked a little about like they go crazy in the tank, but were you able to see things like this in the wild too?
So not with our bonefish. a future study that we're about to start and we're working on would be collecting our samples. So I collect my samples by drawing blood from these fish and then also putting in a tracking tag and using telemetry to see the movement and see, okay, what's the level of drug? Is the movement different? But other studies, particularly those from our collaborators in Sweden, they have in a full lake study, which is pretty neat. They put in perch that were tagged. Some of them were exposed and some of them weren't exposed with an anti-anxiety drug called oxazepam. So it's in that family of benzodiazepines. And the fish that were exposed, when they put them in the lake, immediately dispersed. So they didn't have their like behavior to school up. They moved a lot more. And then they also tagged pike, and they could see the pike going after all these exposed fish. The ones that weren't exposed, they did what they were supposed to do. They stayed near where they were released. They schooled up. So you could be predated on more. So we were saying it increases boldness, it decreases anti-predator, but it also can affect reproduction. It could change spawning behaviors. So with salmon, they'll migrate more, salmon smolt. So when they're going out to the ocean, they migrate more quickly, and then they're eaten much more frequently. So it's all these different behaviors that have like really important implications for survival that are all affected by these drugs.
Yeah, because like salmon, they get fed on by bears whenever they're going upstream, and
Oh
other
yeah,
animals, and not just aquatic, fish. They're also
yeah.
being consumed by land mammals as well.
Yeah, it these drugs that are in the water, they can leave the aquatic environment and enter the terrestrial environment in a way that you're mentioning there. It could be a bird eating a fish. In freshwater environments, it could be insects that emerge from the stream and fly away, and they contain like spiders. They contain a lot of these drugs, and it can accumulate to a pretty high degree. Yeah, so it's not just limited to the water. It's everywhere.
What other fish have you looked at that that has pharmaceutical drugs inside them?
So us specifically, we've only tested so far bonefish, but we're also doing a study, samplings happening right now and through the end of the summer, um, to look at redfish. So when we did the bonefish, we got these results, and our dirty little like secret is that we're trying to use this as information that helps with wastewater treatment reform. So that's our what is it? Arterial motive?
Yeah,
Ulterior.
ulterior,
Ulterior
ulterior.
motive. I
Yeah.
found it. That's our ulterior motive, is to use it for wastewater treatment. It's just another indication that our wastewater is reaching the environment and it has stuff in it that's bad. But we realized, okay, when we're in Tallahassee, the only county that cares is Miami-Dade and Monroe. So in the South, because that's where bonefish are. We're like, okay, let's test redfish in every single region. So 9 different areas. So it applies to everyone in Florida. And then we're adding in the elements of consumption of that fish. Since people love to eat redfish, you guys do in
Oh
Texas,
yeah.
we're going to test the blood and the muscle tissue. So we'll see what's in the blood and see what's in the muscle tissue and get a pretty big idea of what's happening like statewide.
Man. So bonefish are native to Florida, so there's no bonefish in Texas?
No, none in Texas.
Okay.
Really, it's just Florida. Sometimes they accidentally get swept up in the Gulf Stream to, let's say, like maybe North Carolina or something. As far as that, they're in Hawaii. They're in kind of like every circumtropical area. So Hawaii, around Australia-ish, Christmas Islands, and the Caribbean. So
Yeah.
they're pretty widely globally distributed. But in Florida, just in South Florida.
Were there hotspots in Florida that showed higher rates of pharmaceutical drugs compared to others? Like, what was the worst spot that you got your
Yeah.
samples from?
Yeah, so that's a great question, and probably the first example of a couple that we'll go over where I was wrong. So
Mm.
like in this, it's interesting with the scientists, we can hypothesize things and be completely wrong, and that's like cool and okay. It's an interesting job. But we want to understand like, okay, are there regional differences? So in South Florida, we had 5 different regions: Biscayne Bay, which is directly abutting Miami, the upper Florida Keys, lower Key West, and then we went all the way out to the Dry Tortugas, which is about 100 miles from Key West, just way out there. So knowing what we know, we were like, okay, Biscayne Bay, most certainly the highest, right? Because there's a ton of people that live nearby there. There's a lot of septic systems that are there, wastewater treatment plants, and the list kind of goes on. And then Dry Tortugas we threw in there, and we were excited about it. Like, okay, that's our control. It was not that way. Dry Tortugas was the highest
No
by a
way.
good margin. Biscayne Bay was up there too. Key West and the lower keys were lower, and the upper keys was higher. So we were completely like dumbfounded when we got those results. It was like, wow, Dry Tortugas, really? But yeah,
So what's the reasoning or the guess why because that, yeah, that makes the perfect sense. The more heavy populated the area, the more, waste streams that are in the area, you would assume automatically that the pharmaceuticals are heavier in those bodies of water. So
yeah.
I guess what's the guess?
Well, it's interesting. So, like all those assumptions, they're really the ones that I had, and they're pretty sensible. It makes sense. But contaminants, pharmaceuticals, they kind of behave differently. So it's like in the case of pharmaceuticals, the most important factor might not be that it's near a lot of people. It might have to do with how's the wastewater handled. So it could be just a few people and a ton of drugs. So that being said, I looked at the type of drugs that I was finding. And in the dry tortugas was one of the few places that every single fish had acetaminophen. Like no acetaminophen in the upper keys or lower keys, a little bit in the lower keys. So every fish in dry tortugas, most of the fish in Biscayne Bay. And that drug's interesting. And we haven't gone into this yet, but there's a whole nother aspect of how wastewater treatment handles these drugs. But acetaminophen is almost completely removed from wastewater treatment. But in a septic system, it's not removed at all.
Hmm.
So if you're finding it, then it could be indicative of that being the source, septic. And there actually is one septic system on the dry tortugas. So that was my thought, like, okay, everyone's taking it and it's absent elsewhere. It must be potentially a localized source. But what's also interesting about the dry tortugas is it's kind of like in an eddy where multiple currents will meet. So it could be that it's being brought from elsewhere to that area. But I still kind of lend towards that first thought, because if it was being brought from elsewhere, it would be like, let's say Key West or the Upper Keys. It should have a similar signature to those fish, but the fish in dry tortugas were totally different. So it was crazy. I got those results immediately, called a couple people, trying to figure it out.
Listening to you talk, when I first read that article, I was like, man, people are flushing a lot of drugs. They're getting rid, or they're losing them. But they're not even just doing that. It's in their, I imagine it's in their urine, it's in their stool. So even in the perfect world example of everyone is able to control their drugs and keep them bottled up and safe. It's still, there's so many people taking these things that it's going to
Yep.
excrete somewhere and somehow. So it's going to make it to the water some way, some form or fashion, right?
Exactly right. The water is the end result, end of the line in every single scenario. And as Americans, we have a crazy appetite for drugs.
Yeah.
So we consume over 50% of all of the pharmaceuticals produced in the world. So on average, there's about 6 billion prescriptions, and each American on average will have about 18 30-day prescriptions a year.
Holy
So it's like
crap.
5,000 different types of prescription medications. And then let's say we'll throw in over the counter, there's 300,000 different kinds, and we know even less about those. And that's just a lot. So taking all of these drugs, which oftentimes, let's say, could be overprescribed. Another interesting thing is the prescription, the dosage recommendations are all based on your average male. And average male, what does that mean? So you're prescribing like an adult female the same as what an average male would be. That's a whole nother rabbit hole there.
Yeah, yeah, because
But yeah, we're all taking these drugs. We, like you said, some of these drugs we don't metabolize much at all. It goes through wastewater treatment. And our wastewater treatment plants were just not designed. Like when they were put into place, it was well before we recognized that this was an issue. And it was well before we were consuming nearly as many drugs as we consume now.
yeah, I wonder what's the percentage of people that are on anxiety medication or antidepressants. It's crazy. It's through the roof, especially after COVID, right?
Yeah, definitely. COVID definitely changed prescription rates. Like in the beginning of COVID, it actually went lower. And if you think about it, it's kind of because people weren't going to the doctor for run of the mill things. They're like, I'm staying home.
Right.
So it went lower. Now we're higher, where we continued our trend. But yeah, it's interesting, this prescription rates. But some of the most commonly prescribed drugs are like heart medications, and anti-anxiety is up there. So like the most commonly most common drugs for us that we found were a beta blocker, so heart medication, an anti-anxiety medication, and then crazy enough, a prostate medication, something when you have a prostate issue, trying to manage being able to pee. So that was one of the top drugs. We found a lot of antihistamines, so allergy drugs, everything we're taking. One thing that was really interesting is we found naloxone, which is prescribed to people that are experiencing an opioid overdose, which is all it is. Have you ever heard of Narcan?
No,
That's what
no.
Narcan is. That Yeah. So if you're having, it's like something that most EMTs are carrying now. So if someone's having an opioid overdose, it's like a nasal spray, and it just immediately counteracts it. But there's no reason that I know of to have that drug other than being in an opioid overdose. And we found a lot of that. So that kind of speaks to a couple other different levels and trends of what's going on here.
What are the other avenues? So we talked about waste streams and that sort of thing. But what are the other avenues that these pharmaceuticals are entering the water or the Gulf or areas
Yeah.
of water?
So like our areas, like Gulf of Mexico, Florida, it would be, so we mentioned consumption, us taking them and it not being removed, whether it be wastewater treatment or septic. Um, an interesting thing that we do here, so with our wastewater treatment, it cleans our water, it removes like organic things, and so you get this biosolid waste. And we, under the pretense of it being fertilizer, which it's not, we spread it over pasture land, and we actually pay the landowners to use their property to put all of this biosolid. And it's a thing here in Florida where we pay the poorer counties. So we're taking Miami-Dade and we're paying these people to put it out there. So that contains all of these drugs. It rains, it washes out. So runoff from sources like that, livestock, one of the drugs we found is really frequently used antibiotic for animals from hospitals. So hospitals and nursing homes in particular, which we have a ton of in Florida, they're not regulated any differently than a personal household as far as what they do with their waste and what they do with their drugs. So like drugs aren't considered a hazardous material. So like you and I, we have no regulations as to how we dispose of them. There's a lot of different sources. Yeah.
Are there any tools or tricks or is there anything that could be done to stop this?
Yeah. That if you were to compile a list of all the different options, you would always end up on wastewater treatment. So it's kind of like, regardless of whether or not it's me taking it and I pee it out, or someone's taking unused drugs, putting it in the toilet, it's wastewater treatment is the last step that kind of keeps it from getting into the environment. Like, we're not going to ask people to take fewer drugs. We need them. They're important, right? It's wastewater treatment, and the technology is there. We don't use it in the United States. The countries that are doing well with it, Sweden, Switzerland, and Germany. So it's an extra step that you add to wastewater treatment. It's called ozonation, and it removes these pharmaceuticals really well.
What does that process involve? Is it more chemicals in the water, or what does it look like?
So it's using ozone, so
Okay.
O3, and it's using that. So you produce the ozone, and it's using that to take out these different types of contaminants like the pharmaceuticals. So it's an extra step. Like, we use traditional wastewater treatment. It's got like primary, secondary, and tertiary treatment, and it's would be put in the existing wastewater treatment plants and used to remove these additional contaminants.
What kind of support are you receiving? So now that this report, I think maybe it got first popularized maybe at the beginning of the year, February, I
Yeah,
think is
yeah, we released it officially on February,
okay.
and it went pretty crazy for a few months, a little bit of a lull. And then, I don't know, maybe a month ago, CNN randomly picked it up. It was on the Daily Show, which was crazy.
Wow.
Trevor Noah was doing his jokes and segment on all this. He called it the most Florida story he's ever heard, fish on drugs. He's like, that makes sense. Florida, right?
Are organizations or individuals that are real wealthy, are they stepping up to help? What kind of support are you getting?
Yeah, I mean, so we hadn't even left the conference room when we presented this research in Tallahassee, and the executives that we were with from Bonefish Tarpon Trust were like, okay, that one senator said, okay, I'm from North Florida, I mean, I like to catch redfish. I don't know what bonefish are. But like, you know what? We need to do that. So right then and there, Bonefish Tarpon Trust helped support the study we're doing now to really make it harder and harder to ignore it when it comes to the people that are actually in charge of doing something about it.
Yeah, so redfish would catch a lot of eyes.
Yep.
Um, what is the other fish that you have to go spear at night? I don't know why I'm forgetting it.
Spirit Night,
A lot
snapper, different snapper species.
snappers, but there's one that's like flat. I forget the name of it. I don't know why. It's like
Oh,
a
flounder. When you
flounder.
go gigging.
Yeah,
Yeah,
yeah, yeah. That would be
yeah,
a good one to study too, because everyone
definitely.
flounder. I don't know if that's on your radar or not.
Not yet. I mean, I'm in love with red. I love red fishing. I think redfish is awesome because it's Florida, it's Texas, Louisiana, I
Yeah.
guess Alabama and Georgia too, North Carolina, South Carolina. You know, we're really covering the whole southeast when we're looking at redfish.
So what's the timeline look at on this study with the redfish? Are y'all? You said you're actively doing it. When are the results are expected to come out?
Yeah, so we're gonna have that completed by the end of the summer and have everything analyzed in time for the Bonefish and Tarpon Trust Symposium. So they have that early November just to bring together like all the science that they're doing and publicize it. So that would be the point where we would release those
Oh,
findings.
that's very quick.
Yeah, this is crazy, crazy turnaround.
So what does that?
Yeah,
I guess what does this process look like when you're gathering the data? You just out on water, you're catching fish, and then you said you take the blood.
yeah. So that's the other element that makes this really difficult is redfish and bonefish. Bonefish in particular are very difficult to catch here. It requires a lot of expertise. You need to understand uh, the tides and all of the different variables that come into play. Because you know you could have a spot that's a bonefish spot, but they're only there for 1 hour at a particular point in the tide. So it makes it difficult. Like a good day for us on the water would be one bonefish. We're like, heck yeah, awesome. You know, maybe a couple. Our best day was five. So it took a good while to get 93 bonefish from South Florida, which I mean, I'm not complaining, but you know, yeah. So we catch the fish, draw blood. So we flip it upside down, right behind the anal fin. I put a needle in there, find the vein, draw blood. We would take a couple other samples. These fish are so valuable, as I mentioned, like having it there. I'm like, what else can we do? So we took some swabs of the gill and the cloaca to look at diseases. Do they have any viruses? That's another researcher with Bonefish and Tarpon Trust. And then after we do all that, send it on its way. Fish has got a story to tell its friends. Like you wouldn't believe what
What
just happened.
I got
Um,
abducted by aliens.
yeah, it's like a real alien abduction story. What we did to them, but yeah, no, they do well. Release them all. We've tagged a couple of our fish after we released them, and they all survived. So they fare really well with this. And same thing for the redfish, except we are taking those muscle samples, like we're harvesting them so we can look at all the internal organs too, and particularly that muscle tissue so we can comment on human consumption.
Are there any individuals from Texas that are stepping up to help with this process?
Not yet. We're only doing Florida as of now, at least just being, you know, our interests with wastewater treatment here, staying within Florida. But I mean, there are other people in Texas that are doing excellent research on the topic. So, like one of the biggest labs in the field of ecotoxicology that really they kind of published one of the first papers that made people realize, wow, okay, these drugs are doing things to fish, they're changing their behavior, and this matters. Is the Brian Brooks lab at Baylor. So they do a ton of research on this. So you guys are actually doing a good bit of research in the rivers, sampling, in particular, a few of the studies. So I was looking into this a little bit. Guadalupe River,
Yeah.
which I think is also like San Antonio is maybe another tributary of the area.
Yep.
Brazos,
Yep.
Buffalo Bayou, Dickens Bayou. And so they sampled fish there and found almost every single fish having drugs. And they found them at high concentrations as well. But I mean, compared to what we found in our fish, it's a lot more. But they use that same threshold of therapeutic effect. And they found exceedances in bass, catfish, mullet in the estuaries. But this field is new, as I mentioned. So we're kind of still trying to catch up with everything that we need to do.
So I mentioned, I live in Texas and I live on the Gulf, and on the Gulf, there's a bunch of chemical plants, and it's regular people running these plants, right?
Yeah,
And people make mistakes all the time. They're supposed to follow processes and procedures, and I know how humans take shortcuts. So when thinking about that, and then when I drive out there to take my family to the beach, there's people fishing, and they're fishing, less than a mile away from these chemical plants. And the thought always runs through my head is, what the hell? I hope they're not keeping this fish and eating, but I imagine they are. Have
they
you
probably are.
have you looked into anything of, from chemical plants that are relatively close to beaches or rivers, and what kind of chemicals are in those fish?
Yeah. So these fish, they definitely pick up the signature of the water they're in. So if it's in the water and it's a compound that can bioaccumulate, it inevitably is in the fish. Now with pharmaceuticals, they're in pretty low concentrations in fish. So like the immediate risk is low. Like you wouldn't be able to eat enough fish to get that concentration that we were talking about in your blood. But when you think about someone consuming those fish over the course of their entire lifetime, that's consistent exposure at low levels. And right now, we don't know what that does. We just haven't been looking at it long enough. So that's a concerning thought. But a study in Biscayne Bay, and a researcher, Jenny Litz, out of or NOAA, she actually sampled people, so subsistence fishermen, the people that you're mentioning that are out on the bridge every single day, and found like quite high levels of a various number of contaminants, like contaminants we call like legacy contaminants. When they're in the environment, they're there to stay and they keep accumulating, like mercury, for example. You're
Mm.
always told, okay, tuna, you're a pregnant woman, don't eat it, high levels of mercury. But yeah, found in the people eating these fish, high levels of these contaminants. So yeah, outside of a chemical plant, that very likely what's being let out is in those fish.
Do you know of any, like, what are the most contaminated waters in Texas? Because it's summertime here in Texas. Everyone's going to float the rivers. And I was making an assumption on the fish too, real quick, that the fish absorb these pharmaceuticals through the water. Is that fair?
Yeah, that's one of the predominant routes for sure. So
Okay.
just breathing in the water. I mean, it's also through diet
Right.
too,
So
but
I guess where I correlate that to humans is that it kind of happens the same way. If humans are in, highly contaminated water, it happens the same way. We absorb it through our skin. Are there any areas or rivers in Texas that you know of that are highly contaminated with pharmaceuticals or other chemicals?
well, at least with pharmaceuticals, you're not getting a ton, maybe a little bit through your skin. Some contaminants, I'm sure that happens. I'm not familiar with like a specific example. But thankfully, we're not the fish, so we're not breathing the water. But you still run the risk of bacteria, E. coli, and that's a whole nother thing. I'm not familiar with what areas in Texas are obscenely contaminated, but you can look at areas that, like a large river system that services a large population that might have wastewater treatment plants on it, and those estuaries, and look at those with a little bit of a cautious eye, right? Just to understand, like we mentioned early on, everything ends up in the water, and eventually at the end of the line, it's all deposited. So if you have canals feeding into these rivers and large populations, those are the ones that you would think, okay, there might be something here from all the people.
What's the plan for? So you want to do the redfish study? Are y'all making plans to start other fish and maybe even going into maybe humans that consume these fish, or what does the future look like and what's the end goal?
Yeah, so I guess the process is, exactly what we're doing. We're at step two now. So step one, is it there? Yes. And is it concerning? The answer is yes. Okay. Now, how do we expand it? So we're looking at, is it there everywhere in Florida? And is it in a fish that we're eating? And is it a risk to people? So essentially, those two questions we're asking with the second study were the first questions we get asked talking about our study. Oh my gosh, it's in the fish. Is it in the fish we eat? Are we getting it? So we're addressing that question with that one. And then based on what we find there, expanding out potentially into other species, um, and just kind of go from there. So really a stepwise, and the end result, the end goal is we're informing um, ourselves about what's happening to our fish and what's happening in our ecosystem. But I think this is an interesting type of water quality issue that you don't have to care about water quality or the environment really to be concerned, because you're like, oh my gosh, drugs. I know what these do. I know what they are. You know, if I were to tell you, man, the chlorophyll A is really high, you might be like, whatever that means, you know. But drugs, antidepressants. So it kind of garners a little bit wider of an audience. And so if we tie that in with this is an issue of wastewater, then that is really the end result. Can we use this information to help inform better water management practices? Because water is incredibly valuable. For us here in South Florida, our Everglades is starving for fresh water. Biscayne Bay is starving for fresh water. And we want to know that the water that we do put into it is clean, and find better ways to clean water so we can put more water into it. Like here in South Florida, we use ocean outfalls in a couple areas, but we use deep well injection. You guys don't have that in Texas. We inject a lot of water, and realistically, that's just wasted water. So we don't get to use it. We don't reuse it. It's not drinking water, and it's not going in the environment. So if we can have cleaner water and use it more efficiently, that's the end goal.
Is there anything that could be done for the ocean? So we talked about the wastewater, like putting a stop to it, another, integration of technology that can better block the pharmaceuticals and other contaminants. But what about the ocean that's already contaminated? Is there anything that can be done to clean it up?
There's It's such a big problem, right? it, it's massive. The answer is realistically no, to my knowledge of anything that would be substantive enough to actually make a dent in it. You know, like maybe the same technology that we were talking about, the ozonation. There's some people doing research and actually building mobile ozonation like trucks, and a couple other water treatment trucks like that they'll bring to, let's say, Tampa Bay when it's experiencing a red tide, and try to flush and clean out the water. But that's just like such a point source solution of sorts. It's only addressing right there. Once it's in there, it's in there. You know, once things get out, it's that's a great point. I mean, we never do this, but take precautions before we actually do something. So before we do it, is this going to be an issue? And then let's reconsider. But you know, human nature, we just go for it and be like, oh crap, there's a problem.
You mentioned Sweden didn't have the same levels in their bonefish. Or what other countries have lower levels than Florida?
So in Sweden, it was a different fish. They were
Okay.
doing so they test a couple different fish. They test salmon, perch, you know, the types of fish they have there. They still do find a lot of it, and high enough levels that it actually could be doing something. Um, Wherever people are that are taking drugs, it is fairly safe to say that this is in the water. So there's a really recent paper. It came out this year. It was a really cool one. They tested rivers around the world, so rivers everywhere, and some rivers that had never been tested before, some that had, and they found that it was some of the most contaminated rivers were really rural and not that many people. So this is a problem that can be in places that we don't expect, like the dry tortugas with our bonefish. Um, so it's something that's all over the place.
We, I talked to this girl in Europe that's she's like an anxiety coach, and so she's all into the numbers and research of how many people in the U.S. versus Europe are on anxiety medication. So I'm wondering, I'm sure there has to be a correlation of, the number of people in Europe and their waters, I imagine, are a little cleaner than American waters because of how many people are on antidepressant or anti-anxiety medication compared to the countries that have lower anxiety levels.
So the U.S., like what she was saying from her research, U.S. we're a lot higher than European countries as far as like the amount of people that are taking them.
Yeah. Yeah.
Okay, yeah. I mean,
So I'm wondering,
I,
and Europe, I mean, just as a general look, if you look at people in Europe, they just look healthier. You know what I mean? They
Yeah.
look, they're not like, fat and overweight, but
No,
American,
yeah, it's funny you say that. I've been to Sweden a couple times to work with our collaborators there. So it's Thomas Broden and Jörger Fick over at Umeå University. And I remember when I was coming back, I knew that I was getting close to the United States when I started to see fat people in line at customs and what have you. I was like, oh, okay, I haven't seen one of those in a
I'm
while.
home. I'm home, right?
Yeah, right. I
That's
was like,
crazy.
okay, we're here.
So
Um,
I started following a bunch of Europeans, and their lifestyle, um, even their consumption and the way they eat of food, their type of food is just completely different. And I mean, I'm seeing it on Instagram, so it's only a portion, a small
yeah,
percentage of what I'm seeing. But I imagine if they're healthier, they have cleaner waters there too.
you're
If they're
touching on a really great point, which is, we prescribe a lot of drugs for things that might have a different solution. If we were to be healthier, overall exercise a little bit more, maybe eat healthier, um, it's possible, exercise, good sleep, eating healthy, that can affect and help with depression. Doctors will always say, okay, exercise, sleep, eat well. And then if you're still experiencing symptoms, then we'll prescribe. So, yeah, if we're healthier, that could be something that would reduce the amount of drugs that we have to take. And then again, fewer drugs entering the environment.
Yeah, man, I'm interested about this redfish study. We'll have to link up again after it's complete, maybe before the big conference. What is
Yeah.
the I guess the organization called the Bone and Fish?
Bonefish and Tarpon Trust.
Okay,
Yeah.
and
So they're doing it.
that's based out of Florida.
Yeah. So they're out of Florida, but they do research all throughout the Caribbean, the Bahamas, Belize, Mexico, Cuba, Puerto Rico. And now they're funding research in crazy places like Christmas Island and the Seychelles, if I'm remembering correctly. But yeah, South Florida, really focusing on those three fish and the habitats. And now redfish. So we're going to have to add like a redfish to that logo. But I'm super excited too, because we're looking all over the place in Florida. My project really, it answered some questions, but I had so many more after our results. And so it's really cool to expand it.
How far do redfish move? Like if they're in Florida, do they stay in Florida, or is it possible for them to come to Texas, and vice
There
versa?
could be, yeah, there's definitely populations that are a little bit more localized, but there's definitely movement between those, between some populations. I'm not as familiar with redfish movement as far as the bonefish goes, which I'll just throw that in there. They're a good sort of sample of an area within like 15 miles on average. Um, so that's a great point you bring up. That really does influence like what we're finding. Are we getting a picture of exactly where that fish was caught, or is this fish showing us exposure from all over the place?
Yeah.
And we'll understand. We'll be able to better understand that when we actually sample all over the place and see, is it the same? Is it different?
Yeah, I need
Yeah,
to have like a documentary crew follow y'all. This kind of reminds me of. Have you seen the documentary? I think it's called Seaspiracy.
I know it. I don't think I've seen it.
I
What was that one?
well, I might be getting them confused. So there, I found one about um, the amount of plastic being dumped in the ocean that we don't know about, and a lot of it is like fishing gear. Like people think of plastic as in straws, but like they don't realize that there's more fishing gear. These nets that get left after these big boats come in and drag the bottom of the ocean, and those nets just get left there. But it was a documentary. I can't remember if it was on Netflix or something, but it also talked about how the fish are getting contaminated from this plastic that we're leaving in the ocean, and it's getting dumped from chemical plants into the ocean. And it kind of reminds these fish are just super contaminated if they had this plastic. Now they got other chemicals and they got pharmaceuticals. Like it's like there's no hope almost. It's kind of overwhelming a little bit.
Poor fish, poor animals,
Poor
right?
humans, man. Poor humans, because we're
Right.
gonna eat those
The
things.
things that we do to them. So yeah, we got fish now with microplastics in their flesh, and now they've got drugs. And I mean, I feel bad for my bonefish. Like I said, some of them 16 different drugs. Like I don't know, show me a person with that many drugs that is fine.
Yeah.
And
No, there's no hope,
a
man.
lot of, because that's the other thing too. We were not finding one or two. Our average is seven different drugs in a fish, and like we go to a doctor and we're getting a new medication, they'll ask, what else are you taking? Because they're trying to understand what's going to happen, what interactions. So now we're throwing in a bunch of different drugs that can interact with each other in really difficult, if impossible, ways to predict like what they'll do. So that's the other thing. It's not one, it's not two, it's three. It's a whole cocktail of drugs that are in the ecosystem exposing our fish.
Man, if I was closer, dude, I'd definitely help you document some of this stuff, because I think this is, especially the redfish, and then as you expand to other species like shark,
Yep.
I guess the big commercial fish,
Yeah, like you mentioned, it'd be interesting. So our fish, that the bonefish and the redfish, are all coastal and they're not pelagic species. So it'd be really cool to start testing pelagic fish and see, is it in them? So these fish that travel open ocean long distances. I mean, some studies have sampled open ocean water and they find the drugs there. So it would definitely provide a whole nother piece of the puzzle to understand what's happening with these fish that actually swim long distances in the open ocean. So I'd love to start sampling mahi,
Yeah.
tuna, right? Because these mahi, they travel all up Florida, North Carolina, the East Coast, the Gulf of Mexico, and then everywhere, right? So that's a whole nother. We keep kind of emphasizing the fact that this is like a new field. There's so many questions that we don't know the answer to, and there's so many questions that we don't even know that we should be asking yet, because it's new. Like one of the seminal papers, again, it came out of Brian Brooks and Baylor, was only published in the early 2000s. So we haven't really been studying this hard since then. And then you know how things work, it's slow. So let's say within the last 10 years, and then like our study, as far as the scale goes, is one of the first and largest in like a marine system. So there's just so much more that needs to be done to really understand what's going on. But again, thankfully, people care. Like we're having this conversation right now, and we put out our results, and the response was really comforting, to be honest. The fact that so many people cared about it and they were interested, like, oh, something's going on. What is it? Yeah. We want to know.
Well, Nick, I appreciate your time today. And I'm curious, man. I want to stay in touch. Maybe we can link up again before that organization. We can have another podcast to see the results of the redfish, because I'm really interested into it.
Yeah, totally. Let's throw that on the calendar so that we can reconnect. Again, this is November.
Okay.
So we can reconnect by then. I'm excited too. It's going to be awesome to see you with the redfish, to really understand, is this everywhere? Which, I mean, my guess is yes. A very well-educated guess, a safe bet. But now we'll know.
Yeah. Well, man, I appreciate your time.
Yeah, dude, thanks for reaching out, and I appreciate the interest and actually helping spread the word. You care, people will care. It's awesome.
Absolutely. All right, man. You have a good one.
Yeah, have a good weekend.
All right, buddy. Bye.